This is the end. Trillions upon trillions of years from now, the last star in the universe will flicker and die. No more light, no more heat, no more life. Just darkness. Forever. But before that final moment, there will be one last light. One final star burning alone in the infinite void. Today, we are traveling to the end of time. We will witness the death of stars, the collapse of galaxies, the evaporation of black holes, and the final fate of the universe itself. This is the story of the last light, and what comes after. Let us begin with now. The universe is 13.8 billion years old, and right now it is in its golden age. There are trillions of galaxies in the observable universe. Each galaxy contains hundreds of billions of stars. There are more stars in the cosmos than grains of sand on all the beaches on Earth. Stars are still being born. In the Milky Way, about 7 new stars form every year. Gas clouds collapse, fusion ignites, new light enters the universe. But this era is temporary. Star formation depends on hydrogen and helium, the raw fuel of creation. Every new star consumes a little more of that supply. Star formation peaked about 10 billion years ago. We are already past the universe's prime. We are living in the twilight of the age of stars. And this age will not last forever. Fast forward 100 trillion years. By then, the universe has changed dramatically. Most of the bright stars we see today are long gone. Massive stars burned fast and died young. What remains are red dwarfs, small, cool stars that burn their fuel extremely slowly. Red dwarfs can live for trillions of years, but even they require hydrogen. By 100 trillion years from now, nearly all usable hydrogen will be gone. Somewhere in a distant corner of space, the final star will ignite. It will be small, dim, unremarkable, but it will be the last star ever born. After that moment, no new stars will form. The cosmos will never light up again. That final red dwarf will burn for trillions of years, and when it dies, the age of stars will be over. By 1 quadrillion years, every star is dead. The universe enters a new era, dominated by remnants. White dwarfs, the cooling cores of dead stars. Neutron stars, collapsed beyond imagination. Black holes, gravity at its most extreme. White dwarfs still glow faintly, radiating leftover heat. Over unimaginable time, they cool. Eventually, they become black dwarfs, cold, dark remnants drifting through space. The universe grows darker, colder, quieter. Light becomes rare, then almost non-existent. By 10 to the power of 20 years, even planets cannot survive. Over vast timescales, gravitational radiation slowly drains orbital energy. Worlds spiral inward. Eventually, planets fall into dead stars or black holes. Each impact releases a brief flash of radiation, a final flicker of light in a dying cosmos. But these events grow rarer and rarer. Space becomes emptier. By 10 to the power of 30 years, even galaxies fall apart. Gravity once held them together. Over immense stretches of time, gravitational interactions fling stars into intergalactic space. Galaxies slowly evaporate. Dead stars drift alone through the expanding void. No structure, no clusters, only isolation. Then comes the era of black holes. By 10 to the power of 40 years, almost everything else is gone. Stars gone, planets gone, galaxies dissolved. Black holes remain. They do not burn fuel, they decay incredibly slowly. For unimaginable spans of time, black holes dominate the universe. Occasionally, a stray object wanders too close. It is torn apart, heated to extreme temperatures, and swallowed. A brief flare of radiation marks the event. Then, darkness returns. Mostly, black holes drift alone. By 10 to the power of 65 years, something even stranger may happen. Protons, the building blocks of matter, might decay. We have never observed proton decay, but some theories predict it. If true, all matter would eventually dissolve. White dwarfs would disintegrate, neutron stars would evaporate, planets would fade particle by particle. Only black holes, photons, neutrinos, and perhaps exotic particles would remain. If proton decay is real, the universe becomes emptier still. But even black holes are not eternal. Over unimaginable scales, quantum effects allow them to slowly lose mass. They evaporate. Small black holes vanish first. The largest survive the longest. But by 10 to the power of 100 years, even the biggest black holes disappear. In their final moments, they release a burst of radiation, a last explosive flash of energy. That may be the final light in the universe, the final flash, the end of everything that once was. After that, only darkness remains. No stars, no black holes, no structure. Just faint radiation drifting through infinite space. The universe reaches maximum entropy. No usable energy, no change, no possibility of work. This is heat death. Cold, silent, endless. And it may last forever. Or perhaps not. Some physicists believe that even in this darkness, something might happen. Quantum fluctuations could, over unimaginable times, randomly create a new universe. Some propose a cosmic collapse, followed by rebirth. Others suggest that our universe is only one among many. But there is no evidence for these ideas. They remain speculative, beautiful but unproven. So here's the question. If everything ends, if all stars die, if even black holes evaporate, does anything we do matter? Some people find this thought depressing, but there is another way to see it. The universe will end, and that is exactly why this moment matters. We are temporary, but we are real. For a brief cosmic instant, the universe became aware of itself. It formed stars, planets, life, consciousness. Through us, it reflects on its own existence. That is not meaningless. That is extraordinary. The last light in the universe will die, but before it does, it will shine. And right now, so are we. See you among the stars while they last.